The Safest State to Relocate to by Ashton D'Alessio. When choosing to relocate yourself or your family, one of the most important aspects that everyone considers is safety. But what exactly makes an area safe, and how is it able to be measured? Crime rates, pollution, and weather severity are top of the charts when it comes to ranking safety. My plan to answer this question is gather variables from different datasets, all related to crime, pollution, and weather. Extract the variables needed into a new dataset. From this new dataset, I will create an algorithm to determine which state is the safest based on the averages of the variables. Using this ranking, I will test for sensitivity in the model. Let's dive into the first dataset used, the crime rate data. This dataset is describing the crime rates for violent and property crimes from 1960 to 2019 in the United States. It has 3,115 entries of 21 total variables. The variables used out of this dataset are the state, the year, data rates property all, and data rates violent all. I used the string, the head, and the summary functions to inspect this dataset. Finding the variables that were related to my research question, the ones listed in the last slide, I created a new dataset titled CR1 with only these variables. Using CR1, I used the group by, summarize, and mean functions to find the national average of all property and violent crime rates in the dataset. I then used mean to calculate the individual state averages for all property and violent crime. I saved these individual averages as named values to be used later to create a final dataset. The second dataset I used is the weather event data. This dataset describes 8.6 million recorded weather events sourced from 2,071 airport-based weather stations nationwide, spanning from 2016 to 2022. This data was chosen off Kaggle.com because of its usability score of 10 and its airport-based sources. The variables used in this dataset are the state, the end time UTC, and the severity. Making a note on severity, it is the only variable that is qualitative data, and it ranges from light, moderate, to severe. For the weather event dataset, I use string, head, and summary functions to inspect the data. Finding the variables that were related to my research question, I created a new dataset titled WE1 with only these variables. I changed the observations under the state variable from the two-letter state abbreviation to the state's full name in order to have no problems when merging these datasets later. I then made a two-way prop table counting the amount of severe weather events in each state and saved it as WE ranking. The third dataset I used is the pollution dataset. This dataset is describing daily inputs of metrics measuring the air quality related to 4 pollutants from 2000 to 2023. It has 665,414 entries of 22 total variables. This dataset was chosen on Kaggle.com for its usability score of 10, and its source from the EPA seems to be reliable at face value. The variables used in this dataset are the state, the date, and 4 different pollutant air quality indexes, and the pollutants are as follows: the ozone air quality index, the carbon monoxide AQI, the sulfur dioxide AQI, and the nitrogen dioxide AQI. For this dataset, I used the string, head, and summary functions to inspect the data. Finding the variables that were related to my research question, I created a new dataset titled P1 with only these variables. The 4 variables used for this dataset are measures of different air pollutants. I made an algorithm that had all 4 pollutants weighted equally to give a ranking for total air quality index for that observation or a specific day. I then used the mean function to find the average ranking for each individual state related to total air quality index, making sure to stay in alphabetical order. Once I had all the variables that I needed extracted into different data sets, I was finally able to create my full data frame. I created a column of values for each variable out of the 3 data sets I wanted in my full data set, making sure to keep the states in alphabetical order. When going to create this data frame using data frame function, I received an error saying we ranking only had 48 values, while state had 50. I created what I could into a data set named part data, and then created a new state variable named state2 with only the 48 states listed in we ranking. I then created a new data frame with the we ranking and new state2 names into weather ranking, and then merged them with the merge function part data into the full data. After completing full data, I made a series of graphs to look at the variables with a different perspective, specifically box plots and histograms. Also, using the summary function on full data was extremely helpful. After reviewing the dataset full data, my hypothesis is that North Dakota, West Virginia, and Maine all have a pretty good shot at being #1 for the safest state to relocate to. Using the full data set, I created an algorithm based on what I perceived to be the most important to safety. I then used the order function to list the results 1 through 20. I created 5 different algorithms to check the sensitivity of my model. Noticing the large difference in numerical values was skewing my ranking, I used scale to bring all the observations to the same scale, which gave my ranking much more face validity. I then removed each variable to check for sensitivity in the new model. The weights for my ranking are as follows. The violent crime rate is 30%. I chose to give this ranking the heaviest weight, but only by 5% to the next and not more than 10% away from any other variable. This is based on what most people think of a safe area. The very first thought is about the protection of self in the immediate capacity. The second weight is the property crime rate, 25%. This variable was weighted 25% and is equal to weather severity weight, as they both pose a seemingly equal risk to property and assets. The third weight is pollution, 20%. This variable seemed to be the least invasive, but still worth noting when related to safety and health, which is why I chose to give this variable 20%. The last weight is the weather event severity at 25%. This variable was weighted 25% and is equal to property crime rate, as they both pose a seemingly equal risk to property and assets. This is a bar graph showing the final results of the top 10 ranking for the safest state to relocate to. The lower the ranking, the safer the state is. With that being said, North Dakota takes the #1 spot for the safest state in the country on average, with Maine and Minnesota coming in 2nd and 3rd place. Yay, the safest state is #1, North Dakota. North Dakota has the lowest violent crime rate on average, the 3rd lowest property crime rate on average, and the 3rd lowest air pollution on average. Even though it has the 15 highest proportion levels of weather severity, North Dakota takes the #1 spot for the safest state to relocate to. In comparison to the most dangerous state on average, number 50, Arizona. Arizona has the highest property crime rates on average and the highest level of air pollution on average, as well as the 13th highest violent crime rate on average, making Arizona the most dangerous state to relocate to. The final list is here as follows. #1, North Dakota. #2, Maine. #3, Minnesota. #4, South Dakota. #5, Iowa. #6, Vermont. #7, Hawaii. #8, New Hampshire. #9, Mississippi. And #10, Nebraska. This concludes my project to find out where the safest state to relocate to is.